The Astronauts by Stanislaw, translated from the German by the Spirit of Hegel. For the new edition, I intended to slightly revise this book, written 25 years ago, and thus update it, but after reading it through, I realized that this was not possible. I wrote it at a time when the term astronaut didn't really exist. So many, even educated people, confused it with the more familiar Argonaut. Moreover, the planet Venus, on which I set the action, is no longer a completely white patch of sky, since we already know a lot about it, especially thanks to the Soviet probes that explored it. We have therefore learned enough to understand the complete fictitiousness of the conditions and landscapes on Venus, as presented in the novel, in addition to knowledge that no one had access to. There was also other knowledge that I, as an author, didn't tackle. I could have been better informed about rocket construction and even the technical side of astronautics a quarter of a century ago than I did, and finally the year 2000. From the perspective of the 1950s, it seemed to me such a distant future that one could accommodate optimistic dreams of a peacefully united world. But now that it is being targeted by armies of learned futurologists, it requires optimism to restrain itself and dampen earlier all too naive hopes. So if I really wanted to tackle updating the astronauts, I would simply have to write a completely new novel, since I couldn't leave many details, the building blocks from which the whole is constructed, as they are, neither on Earth, nor in the rocket, nor in the sky. But what would happen to the astronauts then? And is it even worth rewriting a book that was written some time ago? It seems to me that it is not worth it. As long as one is able, one should write new ones, but leave the ones already written to their natural fate. Each may defend itself as best it can. Today, this fantastic story is not only full of technical errors and predictions that have been overturned by time, but it is also very naive, in an almost fairy tale-like way. The reader, including and perhaps especially the young, will quickly notice that their knowledge of space travel and as a real phenomenon, even if taken from daily newspapers, far exceeds the author's knowledge of 25 years ago. But if it can no longer be said that this book is a fantastically bold prognostication, it may be permissible to regard it as a specific document of some historical value, namely as an experiment that has been substantially confirmed by time and that has revealed its shortcomings and errors, both scientific and technical and literary. As for the narrative naiveties, they are never justified by anything, and will always prove to be insufficient work. However, the numerous sections whose purely factual inaccuracies have been nailed down and exposed by time are perhaps not worthless, because they ultimately allow for a quite interesting investigation into the relationship between the momentum of the imagination directed toward the future and its rival and adversary, reality. Such a comparison shows that in the field of technological progress, everything usually proceeds faster and in a more revolutionary manner than the imagination can conceive, while at the same time, in the realm of social and conscious affairs, everything proceeds more slowly and with great difficulty. But I do not want to make a systematic reckoning with the astronauts from these remarks. I do not want to balance their assets and liabilities. This book attempts in places to teach, in fantastic lectures, about what already exists today, not only for cosmonauts, for example. The technical parameters of my marks have already been overtaken by the latest generation of mathematical machines in the 1970s. It also contains a problem that motivated its writing, the problem of the nuclear threat, because the history of the destruction of life on the planet Venus is merely an allegory of Earth's problems. This threat still looms over us even after almost a quarter of a century. Perhaps it demands the novel because it updates it. But perhaps those who still read The Astronauts today simply see in it a story full of adventures, albeit far from probable. I can't say anything sensible about this question. Admittedly, I would be surprised if astronauts occupied a permanent position in my work. If anyone still picks up this volume after another 20 years, then I believe it will no longer be to immerse themselves in bold fantasies, but rather to smile at its pages, as we sometimes smile at Jules Verne's, for by then the Cosmocrator and the Marx will already have acquired the patina of antiquity. But whether they will experience such a valued position, that is the question. Stanislaw Lem. Forward to the 8th Polish edition. Part 1. Earth in Distress. The Tungus Meteor. In the early morning hours of June 30th, 1908, tens of thousands of residents of central Siberia were able to observe an extraordinary natural phenomenon. A dazzling white ball rose in the sky, moving at a rapid speed from southeast to northwest. It flew over the Yenisei Governorate, a distance of more than 500 kilometers, and caused the ground to tremble and window panes to shatter. Plaster fell from the walls cracked. In the places where the meteor was visible, a tremendous roar terrified people and animals. The miners in the gold mines abandoned their work. People thought the end of the world had come. Shortly after the glowing ball disappeared, a huge column of fire rose above the horizon, and detonations were heard within the radius of 750 kilometers. Seismographs in all the meteorological stations in Europe and America recorded the shaking of the Earth's crust. The air wave spread at the speed of sound and reached Irkutsk 970 kilometers away after 1 hour, Potsdam 5,000 kilometers away after 4 hours, 41 minutes, and Washington after 8 hours. When the wave was recorded again in Potsdam after 30 hours 28 minutes, it had traveled 34,920 kilometers around the Earth. During the following nights, silvery clouds of such intense brilliance appeared over the middle latitudes of Europe that the German astronomer Wolf in Heidelberg had to interrupt his planetary photography for a while. Gigantic masses of dust had been thrown into the highest layers of the atmosphere by the explosion, and within a few days had penetrated to the other half of the Earth. The American astronomer Abbott, who was then engaged in such investigations, observed that the transparency of the atmosphere had towards the end of June decreased considerably. The cause of the phenomenon was initially still inexplicable to him. Despite its enormous magnitude, the catastrophe received little attention in the scientific world. Fantastic rumors about the meteor circulated for quite some time, in which it sometimes reached the height of a house or even a mountain. There were also reports of people who allegedly saw it after its fall. However, the impact site was usually placed far beyond the borders of their own district. The newspapers extensively covered the event, but no one undertook any serious investigations, and gradually the whole matter was forgotten. 13 years later, the geophysicist Kulik accidentally read the description of the 1908 meteor fall on an old calendar page. Not long afterwards, Kulik travelled through central Siberia and convinced himself that the people's memory of the tremendous natural phenomenon was still alive. Kulik inquired with many eyewitnesses and was finally able to determine that the meteor, coming from Mongolia, had flown over the vast plains and crashed somewhere in the north into the impassable, deserted tundra. From then on, Kulik tirelessly searched for the meteor, which became known in scientific literature as the Tungus meteor. He drew a provisional sketch of the area where, in his opinion, the meteor must have fallen. He gave this sketch to the geologist Obuchev, whom the Geological Committee had commissioned to conduct investigations in the stony Tunguska River basin. In 1924, Obuchev undertook an expedition and reached the Vanovari trading post, in the vicinity of which, according to Kulik's calculations, the meteorite crater was believed to have fallen. He first tried to gather reports from the locals, which was not easy. The Tungus considered the impact site sacred and did not want to reveal the place where the fire god had descended to earth. Obuchev learned that the trees of the central taiga, some days' journey from the trading post, had been thrown to the ground in rows over a distance of several hundred kilometers. The meteor must therefore have fallen at least 100 kilometers further north than Kulik had assumed. When Obuchev published his reports, the Tungusic meteor became topical again. In 1927, the Russian Academy of Sciences sent an expedition under Kulik's leadership, which was to attempt to locate the impact site. Beyond the inhabited areas, the expedition, after weeks of arduous marching through the taiga, reached the wind-torn forest. The forest had been torn down along the meteor's path for a distance of at least 100 kilometers. Kulik wrote in his diary, "I still cannot grasp the enormity of this phenomenon. A very hilly, almost mountainous landscape that stretches many versts, far beyond the horizon. In the north, the snow-capped mountains of the Kushmo River shine. From our observation post, we see complete chaos. The trees of the taiga have been blown to the ground. Tens of thousands of uprooted, scorched trunks, and all around a belt of young trees many kilometers wide, reaching for the sun, for life. One is astonished when one sees these 30-meter long forest giants lying there with their tree tops facing south. Further into the depths of the landscape, the thicket of young forest merges into the spared taiga, and only on the distant peaks do the bare patches still stand out as brightly shining scars." For many days the expedition fought its way through the tangle of fallen scorched trunks that covered the marshy ground. All of these trees pointed with their tree tops to the southeast, the side from which the meteor had come. On May the 30th, a full month after leaving the Vanovari trading post, the expedition reached the mouth of the Chugaguma River, had set up its 13th camp there. To the north stretched a wide valley, surrounded by a ring of hills, like an amphitheatre. Therefore, there for the first time, it was established that the destruction had spread radially. I began, Kulak wrote, to circle the large valley basin rested on the hills, walking dozens of versts over the bare mountain ridges. The tops of the fallen tree trunks lay facing west. Then I circled the basin in a huge arc, heading south. There, strange enough, the fallen trees turned their crowns to the south. I returned to the camp, and from there set off eastward. Here the trees pointed east. I exerted all my strength and walked south again. The tree trunks lying there actually turned their tops to the south. There was no longer any doubt. I had circled the site of the impact. As a fiery congealment of burning gases and solid matter, the meteor had descended here, into this valley with its rings of hills, the tundra and its stumps. Just as a jet of water directed against a smooth surface radiates out in all directions, so too had the stream of burning gases uprooted the forest within a radius of many miles, creating this terrible scene of destruction. That day all the expedition members were firmly convinced that they had already overcome the greatest difficulties, and would soon see the spot where the gigantic cosmic mass had collided with the Earth's crust. The following day they began their march to the lowest point of the valley. They laboriously made their way through the dead forest, some of whose trunks were only bent. The falling wood constantly threatened to bury the hikers, especially round midday, when the wind picked up. They couldn't lose sight of the trees, now here, now there. The trunks collapsed with a deafening crash. and often the expedition members were only able to jump aside at the last second. They also had to constantly watch the ground, as the tundra teemed with poisonous snakes. The interior of the valley consisted of small hills, flat tundra, swamps, lakes, and flooded areas. There too the trees lay on the ground in various directions, but all the treetops pointed toward the rim of the crater. The smaller branches were charred, the stronger ones in the trunk, bark merely singed. Toward the center of the crater, among the shattered trees, the large number of craters were discovered, each with a diameter of 1 or dozens of meters. That was all that this first expedition was able to determine before it was forced to turn back due to a lack of food and exhaustion of its members. Kulik and his companions assumed that, with certainty, that the swampy craters, filled here and there with murky water, were craters in whose depths the fragments of the meteor rested. The second expedition, with great effort and brought machines into this impassable region of the taiga. After the craters had been drained, it was possible to conduct the first test drillings. The work was carried out during the short, hot summer when the oppressive humid air teemed with clouds of bloodthirsty mosquitoes. The drilling was fruitless. Neither fragments of the meteorite nor traces of rock dust were found. The impact of the meteorite creates a mixture of mud and rock fragments that melted and then re-solidified due to the high temperature. Instead, the groundwater, which had now been discovered, threatened to flood the machines. They began the enormous task of shoring up and bracing the affected layer. When the drills finally encountered icy clay, and what was even worse, when the specialists in peat formation, the soil scientists and geologists arrived, they unanimously agreed that the alleged craters had nothing to do with the meteor and that similar phenomenon, which owed their formation to the normal process of peat deposition, could be found everywhere in the northern regions. Such craters constantly formed when peat layers were undermined by groundwater. A systematic search for the meteor began using magnetic deflectometers. It was assumed that such a huge mass of iron would affect the magnetic needle of the compasses, but the devices showed nothing. A path of fallen trees many kilometers wide led from the south along the rivers and streams to the caldera. This caldera itself was surrounded by a fan of uprooted trunks. The energy released during the catastrophe was calculated to be 1,000 trillion ergs. The mass of the meteor must therefore have been enormous. Nevertheless, not the slightest fragment, no splinter, no crater, no spot was found that would have shown any traces of this terrible crash. One expedition after another, equipped with the most sensitive instruments, set out into the taiga. They established a network of triangulation points, examined the mountain slopes and the bottoms of the boggy lakes and streams, and even drilled into the bottoms of the stumps. All was in vain. There were voices suggesting that the meteor might have been made of stone. However, in that case, the impact site would have had to be littered with fragments. However, the whole assumption seemed improbable, since no stone meteor had previously been found in this area. When the results of the investigations were published, meteorologists faced a new puzzle. The expedition members had already observed that the taiga trees had not been uprooted or broken down evenly, and that the trunks lying on the ground did not always point towards the center of the caldera. What's more, here and there, a few kilometers from the caldera, a forest complex had remained standing and had not even been scorched, while a few dozen kilometers further on, thousands of fallen larches and pines were found. The scientists attempted to explain this with so-called shadow effect. According to the report, the blast wave spared those parts of the taiga that were shielded by mountain ridges. The fact that in some places the trees had fallen in a different direction had no connection with the catastrophe. It was claimed that these were ordinary windfalls. Aerial photographs of the area overturned all these hypotheses. The stereoscopic photographs showed that the destroyed forest strips were indeed located conceptually around the caldera, while other forest strips in between appeared intact. The taiga had been destroyed in a way that suggested the explosion had not acted with the same destructive force in all directions. One gained the impression that broader and narrower currents had emanated from the center of the caldera and mowed down the trees in long swathes. For many years, the problem of the Tungus meteor remained unresolved. From time to time, scientific discussions developed in the press. The most diverse hypotheses were put forward. Some believed it was the nucleus of a small comet. Others saw the meteor as a cloud of condensed cosmic dust. None of these assumptions, however, could lead to the correct interpretation of the accompanying circumstances. In 1950, when the story of the meteor had already fallen silent, a young scholar published a new hypothesis that explained all the phenomena and events in an unprecedentedly bold way. 2 days before the appearance of the Tungusic meteor, a French astronomer had noticed a small celestial body appearing in his telescope at great speed and then disappearing. A short time later, the astronomer published his observations, but neither he nor anyone else connected them to the Siberian natural disaster. If that celestial body had actually been a meteor, it would have had to fall to Earth in a completely different region. Only under one condition could it be identical to the Tungusi meteor, namely, if this meteor had been capable of changing its direction and speed at will, like an aeroplane. This assumption, however, was far too improbable for anyone to have considered it even for a moment. And now the young scholar made this very claim. According to his hypothesis, the Tungusic meteor was nothing other than a spaceship coming on a parabolic trajectory from the constellation of Cetus, and with the intention of landing, describing ever tighter ellipses around our planet. It was precisely at this moment that the French astronomer discovered it in his telescope. The spaceship must have been enormous by Earth standards. Its mass could have been estimated at thousands of tons. The creatures inside, observing the Earth's surface from a great height, chose the vast treeless plains of Mongolia, clearly visible from afar, for landing. Their sandy deserts seemed to have been designed to accommodate the spaceship. The creature reached the Earth after a long journey, during which it must have reached a speed of several dozen kilometers per second. Perhaps the braking devices were already damaged, or the occupants had underestimated the extent of our atmosphere. In any case, the craft was headed to white heat by the enormous friction. Was heated to white heat by the enormous friction and air resistance. Due to its extraordinary speed, the spacecraft failed to land in Mongolia, but instead flew over this area at an altitude of over 50 kilometers. It probably had to orbit the Earth several more times before landing, but an engine failure or some other reason had forced the crew to hurry. They now tried to reduce speed and activated the braking devices, which, however, only worked intermittently. The uneven reverberation sounds like thunder to the inhabitants of Siberia. When the spaceship was over the taiga, the glowing gases emanating from the brake pads uprooted and toppled trees. This created the hundreds of kilometers long lane of fallen trunks, through which the Siberian expeditions later had to laboriously make their way. Over the stony Tunguska River basin, the ship lost the forest and other covered terrain were unsuitable for landing. Therefore, the travelers attempted to fly over it and gain greater altitude. They restarted their engines, but it was already too late. The ship, an immense mass of white-hot metal, became unmanageable, sagged, tumbled, and spun around its axis, tossed back and forth by the erratically working engines. The exhaust fumes bent the forest, sometimes close at hand, then again at a greater distance, bringing down the trees in broad swathes or scorching their crowns and branches. The spaceship flew over the outer ring of hills and rose for the last time. There, high above the valley basin, catastrophe struck. In all probability, the fuel supplies exploded with such force that the glowing lumps of metal were torn into tiny pieces. This hypothesis shed light on all the previously puzzling phenomena of the crash. It explained how the forest had been destroyed, why it had been snapped or uprooted in some places, while in others it had merely been scorched, and finally it also explained the strange circumstances that here and there entire islands of forest had remained intact and untouched. But why had this spaceship disintegrated into such small pieces that not even the slightest traces of it could be found? What kind of fuel could it be that, at the moment of the explosion, shone brighter than the sun and scorched the taiga for many kilometers around? The scientist answered this question as well. Only a very specific fuel, he claimed, could so completely disintegrate the strong structure of a spaceship when it exploded. Atomic decay. When the rocket engines failed, a chain reaction occurred among the nuclear fuel stores. A 20-kilometer high column of fire rose, and the giant spaceship evaporated within it, like a drop of water on a hot stove. The young scholar's hypothesis did not provoke the expected response. It was too bold. Some scholars claimed it was based on too few scientific facts. Others, however, argued that it merely replaced the riddle of the meteor with the riddle of a space projectile. Some even described the hypothesis as the figment of the imagination, more worthy of a novelist than a sober meteorologist. Despite all the skepticism, the young scholar undertook a new expedition into the taiga to investigate the radioactive radiation at the crash site. However, he had to reckon with the fact that the unstable atomic decay products had already weathered away over the past 42 years. The research efforts also proved fruitless. The clay and marl layers on the surface of the valley showed such an insignificant degree of radioactivity that no conclusions could be drawn from them, for infinitesimal amounts of radioactive substances are also found in ordinary soil. The differences were within the limits of the barely measurable. So, even the last echo of the discussions in the scientific journals died down. For some time, the daily press continued to discuss the problem of where this spaceship could have come from and what kind of occupants it might have had. However, these fruitless speculations soon gave way to more important matters. Reports on the construction of the huge hydroelectric power plants in the Volga-Don region, on the cutting of the canal bed at the Turgeta with the help of nuclear energy, and on the diversion of the waters of the Ob and Yenisei into the Dead Sea Basin. In the far north, the tundra grew more and more densely overgrown. The fallen tree trunks each year, which sank ever deeper into the boggy ground, the peat deposits, the undermining of ice masses, the melting snow, all these incessant erosion processes gradually erased the last traces of the catastrophe. It seemed as if the mystery would be forgotten forever.